hope you had a great lunch. Today I'm going to talk about a real-world project we had at my company. The main topic is the upgrades. So my name is Julien Riou. I work as a DBA since 10 years now, and I'm actually a tech lead at OVHcloud since 2015. You can check out my website where you will find my previous talks, and of course the slides will be available there right after the talk. If you need to contact me, feel free to go to the link. You will find all the required informations. So a little bit about the context. OVHcloud is a global cloud provider. We are famous mostly in Europe, but since a few years we have been deploying through North America in the US. So we provide multiple services. They can be grouped as bare metal, private cloud, public cloud. Basically, we are a cloud provider. But the common thing is, at some point, to make all those services run, they talk to databases. And for this talk, we will talk about the Postgres databases. So some numbers for the infrastructure. We have 5 kinds of infrastructures: production, development, and more. We manage more or less 230 PostgreSQL databases spread across 50 plus clusters, and some clusters are deployed in highly secured environment. We are not talking about the databases as a service we provide, but the databases that runs everything that's needed for the services. A cluster is one node that acting as a primary, and for high availability we deploy a second node as a replica. We use semi-synchronous replication between them, and to achieve high availability we use patroni that promotes automatically one node if the primary, for example, fails. In front of those nodes, we deploy load balancer. We use HA proxy. We load balance the read-write traffic only on the primary, and we load balance the read-only traffic in other endpoint to the both node in a round-robin fashion. And of course, there is a virtual IP that can move between load balancer if needed. And to perform our backups, we use a file system snapshot backups based on DFS for one reason, because we also manage MySQL databases, and we use the same method for performing our backups between both DBMS. And as I said, we send the ZFS snapshot every night to another infrastructure, isolated and anonymized based on custom rules for giving access to the fresh data to our developers so they can work with a production, near to production data. What's a highly secure environment? Because we are a cloud provider, security is a most important topic for us, and especially we work to be certified as a PCI DSS provider. So we have fine-grade firewall and PGHBR.conf rules. Every connection is encrypted with recent ciphers. we use encryption at rest for the disks, and we log connection and disconnection to see if there is some brute force or something. And every data, every log, every event we gather are sent to an external system for analysis, like a CM analysis. Administrators don't connect directly to the host. They go through something called a Bastion, where sessions are recorded for running commands. And we use multiple factor authentication to connect to every infrastructure. It could be internal tools or via the bastions. We monitor the CVEs for security, and there are audits every year. So we know security is a topic that it's in our core values. But what are the motivation about this upgrade? It's the version. Normally, when I say I displayed it, you should be scared. 9.6 is a very old version. It's not supported right now. So if you run it on production, you should be scared or prepare right now your migration. So yeah, we wanted to get rid of 9.6. There are 5 major releases between 9.6 and now. We are currently in 14. In a few days or weeks, we will be the next release. But this project took place at the end of last year and the beginning of this year. So at that time, only the 14 was available. So there are more features, more performance, more security. So we have chosen to upgrade to the very latest version because it's a big project. We don't want to waste our time. We want to be as the latest, the very latest. This is the objective. And these upgrades bring some opportunities. We can upgrade the operating system. We use Debian mostly. It was in Debian 9. We wanted to go to Debian 11. We wanted to perform some hardware upgrades. We run bare metal servers. They were running on SSDs. We wanted to replace with hardware RAID. We wanted to replace them by NVMe disk with more I/O performance. And PCI DSS security was only applied for a subset of our clusters because, as you can see, it's very heavy. So we wanted to generalize those rules to every cluster we manage. And for Patroni, we used Zookeeper as a DCS. DCS, quickly, for Patroni, is the software that does the quorum for ensuring the leader election. So we wanted to replace Zookeeper by Consul. But there were some constraints before. We wanted to avoid incompatibilities because incompatibilities means errors. So if we upgrade a cluster and we detect an incompatibility, it could mean downtime. And we want near to zero downtime because there are some APIs in front of our databases. They want performance, they want to answer quickly and all the time. We wanted to automate as much as possible the process because there are 50 plus clusters before the next audit. That's the target. So before the upgrade, we tested all our schemas against the new version. Not the data, but the schema, even before touching the data. So we use something called CDS, which is a CI/CD tool we have developed at OVH. So we can perform some tests against both versions at the same time, even before migrating the data. So we have identified a lot of stuff before performing the upgrade. So how we have upgraded? So we will take an example of one cluster. So for upgrading a PostgreSQL cluster, you have mostly three methods: pgdump and pgrestore, pgupgrade, and logical replication. So pgdump and pgrestore, it's a logical export of the data at a given moment. And restore is the same tool, but to ingest the data in the destination. So the pros are it's portable. You can move data between major versions. It could remove the bloats if you have a vacuum that failed over time and you didn't have reorganize the data. You could have bloat, so it will naturally remove the bloat. For small databases, it's great. There is small downtime. But on the other side, for large databases, it could mean an extended period of downtime. We want to avoid that. And it's compatible with nearly every schema, especially those without primary or unique key. PG upgrade, on the other side, is something that only convert the metadata of the cluster. This tool doesn't touch the data, and it restarts the instance on the new binaries. So it's an upgrade in place. So there is a small read-write downtime because it took only the time to restart the instance. Generally, it's short downtime. So it doesn't depend on the size of the data, but on the other side, the rollback procedure can be complicated because it's an in-place operation. Bloat is not removed, so if you have bloat, it will left the data untouched. And it's not portable. For example, if you have multiple operating systems, for example, BSD, or multiple CPU architecture, or slight change, it won't... no, this is not what I wanted to say. It's not portable in the meaning of if we want to replace something on the hardware, this solution is not the solution that solves this problem. And the last but not least, there is logical replication. It's based on a wall, the write-ahead log. It catches every write of the instance. There is also the physical replication compared to the logical, where it's a block copy of every content of the wall from one instance to another, so it's block by block. So logical replication and physical replication are based on walls, but logical replication decodes the content of the wall to do literally whatever the decoding plugin wants to. For logical replication, there are two tools available. There are one available since 9.4, which is PGLogical, and the built-in logical replication. The built-in logical replication is available since version 10. And as I said, we are on 9.6, so we have chosen PGLogical for this project. The pros are there is a small downtime, it's portable, we remove the bloat, but on the other side, it's very compatible with one charset, which is UTF-8, at least for PGLogical. And when you initialize the logical replication, there can be load on the primary instance because you have to copy all the data. And it requires a primary or a unique key. And the last point is very important. It's not compatible with DDL, the alter, create, commands, drop, truncate, and so on. So it focuses only on the DML. This is the solution we have chosen, the logical replication. So the method is we have the cluster on the left, as described earlier. We have the production infrastructure on the top, the development on the bottom, and we spawn we deploy a second cluster with the new version, the PG14, cluster 2 here, and we set up the logical replication between the first primary and the second of the second cluster. 2 weeks before the migration date, we announce to the developers, which are our own customers, hey, we have created another cluster, so we have migrated your development environment to the new version. So please feel free to test it as much as you can, and we are here to hear your feedback. So 2 weeks per cluster is not enough in the absolute, but it was enough for our migration. So you have to have a great communication for the short window. And on the day of the promotion, we promote the new cluster, we remove the logical replication, and we turn the new cluster, the redirect the traffic with the virtual IP on the new set of the load balancer, so the traffic is automatically moved to the new cluster. And we remove the old cluster, and we recycle it, we change the hardware if needed, and it will go back to the stock right after. So now that we have seen how to upgrade one cluster, we will see how we have upgraded every cluster. We used Ansible. It works as a playbooks. There are some actions running sequentially via SSH. And there are multiple community modules. And we use the PostgreSQL DB to manage DB creation, database creations, users, privileges, and some queries sometimes when the modules are not enough for what we wanted to do. But there are also system modules to manage files, services, and so on. And it's open source. On top of that, we use something called AWX. You may have heard of Ansible Tower, which is the commercial release. It's an orchestration of Ansible playbooks. So there is a REST API, a web interface, and a CLI. You can integrate it with the SSO to easily identify which operator perform what actions. And there are some notifications. So you can, for us, we can send some alerting to know where critical playbooks fail and do some action. But we also have instant messages through WebEx-Team. So they can be integrated with corporate tools. And AWX is also open source. We use the Bastion. We have released what we have developed. So the source code for the Bastion is available. And it's like a gateway to connect to the infrastructure, a centralized SSH gateway. There are fine-grained access, so you can attribute, say, for example, this employee can access to this group, which has access to this part of the infrastructure, and everything is recorded with a TTY record. We have a fork TTY rec to add some improvements. It's also available on our GitHub. And it's really heavily used in audited perimeters. So we use it in PCI DSS, and it's certified. But it's great to perform some action, but where? It's not magical. We have to know that this cluster, where the primary of the cluster is. So we have to manage some sort of inventory. And the more dynamic it is, the better. So we use console for service discovery. This is the service discovery of the department. And we have developed a dynamic script that calls console from Ansible to make it a dynamic inventory. And it's also available on GitHub, and it's open source. Everything here is open source. And it goes like this. So AWX goes through SSH via the Bastion to perform actions on servers, but before it knows where to perform the action with console. And the servers automatically register all the information to console. And now the playbooks. So we have two playbooks. One we run 2 weeks before to set up the logical replication ahead of time, and one on the D-Day for moving traffic to the new cluster and promoting the cluster. So the creation of the logical replication goes like this. On the first step, we revoke every DDL from the source cluster. We prevent the developers that, okay, from now, you can't do any DDL at all. And every DDL, I didn't explain that on the slides, goes through reviews, and we, the DBA team, review all the changes with this channel. So we can control the DDL, excepted on some edge cases that we explain at the end. So we set up the PG logical on the source cluster. We create an extension to declare PG logical. We create a node, and we create a set. So a set is something that groups all tables and sequences changes. So we can also use it for a subset of tables, but here we wanted to have every changes. On the third step, we create the new database on the new cluster, and we dump and restore the schema. And on the fourth step, we set up PG logical on the destination cluster. Same, create the extension, the node, and the subscription to link the two clusters together. And it's only for one database. So this playbook handles all the databases that has been discovered on the cluster. So that's why a playbook is useful. It relieves the burden of managing multiple databases. And at the end, we create the application users, Bastion users, because we can have a PGConf command line directly from the Bastion too. It's dangerous on production, just a warning. So we create those dedicated users too. And on the D-Day, okay, everything is great. We have tested everything. So on the D-Day, we perform the last checks to see if, okay, everything is really okay. At the very end, So it's one more security. We start KeepAliveD. KeepAliveD is the tool that manages the virtual IP between the two load balancers. So we start the KeepAliveD on the destination. So it's ready to be promoted. It's not promoted to right away because the whole load balancer still has the virtual IP. But we do it before to have the minimum amount of downtime for the time to start the service and to connect, because connecting remotely via SSH, via the Bastion, can take some time. We force the read-only on the source, so every connection will be forced to be reconnected through read-only. We use the default transaction read-only get through. Okay, this is not perfect. It can be overridden at the session level, but we worked with the developers to check if they are doing some stuff with it, and they don't, so it's relatively okay. And if they do, it's their fault. We have performed all the checks we could have done. On the fourth step, we synchronize the sequences, because sequences are not included in the logical replication. There is some PG logical function to do this, and by default, it's the max value plus 1000. We stop the logical replication on the destination. We recheck the subscription health to avoid any lag, replication lag. We delete the subscription, and at the very end, we stop KeepAliveD on the source cluster, and as it's started on the destination, the VIP will move to the destination cluster. So there is some gymnastics between this. The playbooks are pretty heavy, but once it's written, we can perform it at will. But there are some optimization to do, because the first playbook to set up the logical replication with, for example, 20 databases could take 1 hour just to set up, just to create the extension, and not the initial load, only to create the replication. So we have done some quick and dirty fix for parallelization. We have generated SQL script to perform operation on multiple databases at once. And we have reduced it from 42 seconds in this example to 14 seconds. So divided by 4. Next, we have found that our little wrapper to perform operation via the Bastion and Ansible was very slow because of one thing, the inventory generation. It took nearly 1 and 3 seconds per call to generate the inventory every time. So we have implemented some environment variable to implement some cache, and we have reduced it to 5 seconds. And but it's not the only way to upgrade. We also had used PG upgrade. So there are 4 playbooks. I'm not going into details because it will. I don't have the time. But there is a check playbook to check if everything is correctly set up, because setting up a PG upgrade cluster requires some gymnastics, and it's not at the very last time once the cluster is down that will fail. So there is the playbook that upgrade and the rollback procedure, and at the end when we upgrade the cluster which is in place, we have only upgraded the primary. So all the load goes to the primary. And we use patron it to rebuild the replica in case of an issue. But if it's okay, we upgrade the replicas too. So it's a little bit different than the most common use. We use this PG upgrade for only one cluster. So what we have met with the new version, the very latest version, there are some type changes, unexpected type changes. For example, we use an aggregate, a custom aggregate, to compute the median value, and the types of the function has changed. There are some stuff we are not really proud of. For example, we manage enums directly in the database instead because we have to create schemas dynamically. There are a lot of PL, PGSQL, legacy stuff. So we have seen that the OID column is not implicit anymore. So we had to find a way to generate OID to continue to use this function. But in the end, so to fix this issue, because it's directly in the schema, we had to set up a PG logical. But before starting the subscription, we have updated the schema to be compatible with the new version, and then start the subscription. So we can alter in a compatible way the schema, because logical replication is permissive at some point. Don't convert the schema too far. It has to be compatible. And you have to avoid altering the PG enum directly. We use external softwares that at that time that were not supporting the very latest version of Postgres. Just because we have chosen the very latest right after its launch. So I'm not sure for today, but maybe it's supported right now, but at the time we have done the migration, the upgrade, it wasn't. So we decided to deploy a recent version, not the latest, for those clusters, PG13. So it's a recent version, still supported for many years, so it's okay. Some Debian packages were not available right after the major release, like the PG logical extension, but that time, for the test, we have solved this by compiling those extensions and performing tests on the test clusters. And by the test have finished, the binaries were released as real official Debian packages. But on the bright side, they were available very quickly. So great shout to the Debian packages team that do a great job. But there are also internal softwares. So we have GR security patches for the kernel, for improving the security at the kernel level, that was not included in the installation images at that time. We have a schema migration binary that it's written on Go, and that wasn't easy to adapt it for the new major release, and there is also a session killer. All of those are custom, and not all of them are open source. So we didn't have time to adapt everything, so we chose to stick to the Debian version 10, which is also supported. And for old applications, there are some too recent TLS ciphers. For example, some application we don't control for DBA team are running on Debian 8, which is not supported, but they are here, and they are here to last. So we had to, for those clusters, and also they are not planned to be in the PCI DSS certification. So it's not their priority to update. In the absolute, they need to upgrade, but it's not a priority for the certification because they are not in this perimeter. So we disabled the encryption for those databases to the finest level as possible to avoid to keep the security for every other application, and we have raised the priority for those teams to upgrade their infrastructure. And so the logical replication brings some little issues. We have schemas with tables without primary or unique key, but they are required. So for internal software, we have identified them, we have seen the developer team, and they could change the schema and job done. But for external softwares, we can't change the schema because we lose the support. We have open tickets, and they can take time to update. So for those clusters or databases, we use pgdump and pgrestore for small databases to have the smallest downtime as possible, and otherwise we use pgupgrade. There is something that we have not seen before the upgrade. Some applications have a constraint on identifiers. For integers, for example, they don't expect big values, and even though not so big. So sometimes when they reach 1,000 values, for example, they consider it as an anomaly. So we have faced insert errors due to issues with insert in this identifier, because there is a constraint on this sequence. So it's easily identifiable. We can alter sequence to restart the value and lower the limit, and job done. Another attention point is logical replication comes with a cost. There can be a load on the primary, because logical replication is the subscriber needs to use logical replication slots, and they can be created on the primary only. And once it's connected, there are some big copy operations to copy the data. It's sequentially, table by table, and it can take literally days to finish. And some application we have perform nightly batches with a lot of computations, and we have seen arrays of slow and consuming queries until they starve the CPU resources. It's a nice graph, huh? So we have seen this. As you can see, at midnight, it starts pretty quickly, and we have identified it. It's not a real problem because the server can handle some load. It's just slower than usual. So how we have solved this is for big tables, we have identified that they are not updated often. So we have inserted the data to the new cluster before setting up the logical replication, and we use the backup instances because there is no production traffic on it, so we can copy and do whatever we want without impacting the application. So we have set up this before the logical replication. And at the end, just to be sure, we have performed manual integrity checks to ensure the data is okay. There are also dynamic tables. Some applications create one table per month. They are able to do this. It's a homemade partitioning system. It was created before the the built-in partitioning feature. But those tables are created on the first of the month. And with 50 clusters and 200 databases, it's easy to forget that this database has dynamic table, and be careful not to set up the logical replication between 2 months. So the DDL are forbidden. The application wants to do a DDL to create a new table. Poof, it fails. So failure here means downtime. So before the migration days, we had downtime, unexpected downtime because of that. So we have scheduled, we quickly have stopped the logical replication. We have reallowed the DDLs to create the monthly table by the application. And we have set up the logical replication again and job done. There are also some attention points of the very old software we have in production. For example, one example, PGLogical only supports the UTF-8 charset. We have one database that's using the SQL ASCII charset. It has more than 1 terabyte of data, and it's highly critical. We all have this kind of database. By highly critical, it's really high critical. It's finance data. So we use the PG upgrade method for this database. The plan is to convert the incompatible data with UTF-8 and use later the built-in logical replication from SQL ASCII to UTF-8. It's still in progress. We don't have finished this upgrade, but at least it's running on the very latest version. So what's next? The plan is to, now that we are running on Postgres 14, we plan to use the built-in logical replication. We like PGLogical. It's a great product. We thank this product because we are here right now thanks to this one. But we want to use as much as we can the built-in solution that are in the core. We want to upgrade all applications, of course, because we want to restrict the IP tables and the pghba.conf rules that we have open for all applications. We want to upgrade to Debian 11. And one important thing, and it's really major for us, is we have to change our mindset and not upgrade clusters by clusters, but databases by databases, to be as elastic, as independent as possible, because when you have to upgrade one cluster, it's all the cluster at the same time. It can be an issue to motivate all the teams related to the one whole cluster. And we will be allowed to run multiple major releases at the same time, because before the project we were supporting only one major release. It's not flexible, so we can have multiple at the same time. We already have, because there are Postgres 13, but mostly on 14. And something that we dream is the automatic major upgrade. Now we have the automation. We want to schedule the upgrade and sleep at night, because this is the dream every operator wants. So I would like to give a special thanks to Nicolas, which was the project lead for this. He's not here today, but we have a wonderful team. Arnaud is here today with us. So this project has been performed by everyone in this photo, in this picture. And if you want to be part of this team, of course, we are hiring. We are hiring in the US. Please contact me. We don't have an official job offer right now, but you can contact me and I can do that for you. We also hire in Europe, especially in France, if you are interested, and more. You can find more on our link here. And I would like to thank you to have attended my talk. It's a great pleasure to be here, and thanks to the organizer, PGConf New York. It was great. Thank you. If you have questions. No question?
Did you had to use the rollback strategy for any of the upgrades?
Yes, for the PG upgrade. We have performed the PG upgrade, and before, when we have shut down the cluster, there was some little incompatibilities we haven't seen before, because this is the only cluster we have used. It's the first one, and we can't predict every corner case, and unfortunately there was missing one configuration file at one point. But yes, we have this best practice to have a rollback procedure for everything we perform, because it's very critical for us. So even if we don't run them really, we have them under, so we can push on the button and roll back. And we test them we have test environments isolated from the production, and we test everything on this.
Were there data loss situation in that case?
Sorry?
Were there data loss situation when you did the rollback?
On this rollback, there is no data loss, because on this method, the instance was shut down, so there was error, no insert. But on the other, it depends when we decide to roll back and how. For this method of logical replication, we didn't perform the rollback, but the rollback procedure can have data loss. But before performing the rollback, we must ensure that the team is okay with that. And if not, we have another method, but that can take time.
Thanks.
Did you consider redirecting read-only traffic from clients to the new, upgraded cluster prior to a full cutover as a testing phase?
We don't have that much read traffic, so we can handle all the traffic in one node. In reality, for some for some application, we load balance really, but there are two endpoints, and applications are not always compatible to connect to two endpoints, one for read-only, one for replica. So in reality, the replica endpoint isn't really used, so we don't have considered to use the new because we test. We have upgraded all the test cluster before, so they can test there instead of on production directly.
Any other questions? All right. Well, thank you very much.
You're welcome.